What if gravity isn't actually a force? What if the curvature of space, the very thing that holds galaxies together, isn't built into the universe from the start, but instead emerges, not from mass alone, but from something far stranger, quantum coherence crossing a hidden threshold? Right now, everything we understand about gravity comes from one powerful idea. Mass bends spacetime, and spacetime tells matter how to move. It's elegant, predictable, proven. Planets orbit stars, light bends around black holes, time slows near massive objects. But there's a problem. At the smallest scales, the quantum world, this picture begins to fall apart. Particles don't follow smooth paths. They exist in probabilities, superpositions, entangled states. And gravity? It doesn't fit neatly into that quantum framework. So what if we've been looking at gravity the wrong way? What if space-time curvature isn't fundamental, but emergent? Imagine this. Instead of gravity being inserted into the laws of physics, it appears when quantum fields reach a certain level of coherence. Not just random fluctuations, but a synchronized collective state, like a crowd of people suddenly moving in perfect rhythm. Quantum coherence is when particles don't act independently, but as a unified whole. Their phases align, their behavior becomes coordinated. Think of it like this. One musician playing randomly is just noise, but an orchestra playing in sync, that's structure, that's pattern, that's power. Now imagine the entire universe as a vast quantum orchestra. Here's where it gets interesting. What if curvature only appears when this orchestra reaches a certain threshold of coherence? Below that threshold, reality is chaotic, flat, unstructured. But once coherence builds up, something clicks, and suddenly, space-time begins to bend. Not because mass tells it to, but because the underlying quantum fields have become organized enough to create geometry itself. In this view, gravity isn't a force, it's a phase transition, like water freezing into ice or steam condensing into liquid. When quantum fields become sufficiently coherent, they freeze into curved spacetime. Mass doesn't cause gravity directly. Instead, mass might simply enhance coherence, helping push the system past that critical point. Now think about black holes. In our current understanding, they're regions of extreme curvature. But in this new model, they could be regions of maximum coherence, places where quantum fields are so perfectly aligned that spacetime collapses into its most intense form. Not just a distortion, but a peak state of emergent geometry. And the event horizon, it might mark the boundary where coherence crosses that threshold. Let's go back to the beginning. Right after the Big Bang, the universe was hot, dense, and chaotic. Quantum fields fluctuated wildly. But as the universe cooled, coherence may have started to build. And at some critical moment, spacetime itself emerged. Not created instantly, but formed gradually, as quantum fields synchronized across vast scales. In this view, spacetime isn't the stage where physics happens. It's the result of something deeper, a byproduct of quantum relationships. Reality becomes less like a solid structure and more like a dynamic pattern, a constantly evolving network of coherence. So, what if curvature isn't built into the universe at all? What if it only appears when quantum fields become coherent enough to create it? It would mean gravity isn't fundamental, but emergent. Spacetime isn't given, but formed. And the universe isn't just expanding through space, it's continuously generating it. And maybe, just maybe, the fabric of reality isn't something that exists, but something that happens.